Hey guys, welcome to today's installment of the coordinate geometry series for mathematical studies for IB. Today's probably going to be more one of the significant kind of lessons, I guess, with coordinate geometry, because all of the lessons we've been doing so far have been leading us to this point to do these sorts of questions. Now, before I start, I guess I'm just going to recap a little bit on our formula y equals mx plus c. By now, we should be relatively familiar with our m representing the gradient, which is our rate of change, and then of course our c being our y-intercept. Alright, so that's very important to understand that concept. We've also looked at a number of different ways to find the gradient. Okay, we've got it from the actual equation itself, obviously being in the form of y equals mx plus c. We've looked at, if we were given a graph, we use the rise over the run format. If we're given, let's call it 2 points, we use the y2 minus y1 over x2 minus x1. If we were given the fact that the lines were parallel, we knew that m1 equaled m2, and of course if we knew that the lines were perpendicular, we knew that m1 times m2 equals -1, or otherwise we could call it our negative reciprocal. So you can see we've done quite a lot so far in just finding or just working out how to find the actual gradient. And there are many different ways to do this. However, usually once we've done that, one of whichever way it might be, the next equation we're often, or not, so the next question we're often asked is to find the actual equation of that line. Now this second part of the question is pretty static, I guess. Once we found the gradient, that's the one difference. The next part pretty much remains the same. Okay, let's say for example we were given a question. We'll say this is EG1, where we're given the points A, let's say 2, 3, and the coordinates B, let's say it's 3, 6. Alright, and we're asked to find the equation of the line. Now, either way, there are two things that you're going to work out that we have to have at all times. We have to have the gradient, and we have to know a coordinate. Now I know what you might say. You might say, well, hold on, what if, don't we need to know the y-intercept? Absolutely, and if you have the y-intercept, you are very, very lucky, but it is very, very rare that that will actually occur. Okay, these for me are the two most important things that you need, okay, whenever finding the equation of any straight line. So first of all, the gradient. Now we've spoken about there being 5 different ways to find that gradient. For this particular case, we're going to use our 2-point formula. Alright, so m equals 6 minus 3 over 3 minus 2. That equals 3 over 1, or that equals just 3. Okay, and in this case we have 2 different coordinates. Now it actually doesn't matter which set of coordinates that we use. Alright, you've got to use one of them. Now of course there are different ways to do this, guys, so please don't think this is the sole way to do it, because some of you who have a HSC background might use the point gradient formula. Okay, or certainly if you've done that in year 9 and 10. But for me, we're going to be using this formula y equals mx plus c. Okay, now I've got a gradient of 3 and I've got an x and a y coordinate. So what we're actually going to do, we're going to use these 3 pieces of information to sub things into this equation. So 3 equals, my m is 3 times my x, which is 2, plus c. So again, what I've got there, I've got my y coordinate of 3, I've got my m, my gradient of 3, and my x coordinate of 2. I can then simplify. 3 equals 6 plus c. I'm going to subtract my 6 across to get c equals -3. What we've now managed to do is to figure out what our y-intercept is. So finally, now we're going to finish off by saying is that y equals mx plus c, or y equals 3x minus 3, and that, ladies and gents, is the equation of that particular line. So I'm going to kind of recap that in the next part. So to find the equation of any straight line, so I'll call it a linear function, we need two things. The first thing we need to know is a gradient. The second thing we need to know is a coordinate. And once I have those two pieces of information, we then sub in to y equals mx plus c to find the y-intercept. Now, of course, if you're given the y-intercept, if you're that lucky, then you don't need to do that process. But once you've got that, you then put our y equals mx plus c, but of course, we'll be subbing in the values of m and c, okay, to get that final equation. It all sounds pretty straightforward, but I guess the hard part will certainly come when you're finding the gradient, all right? Because we know there are 5 distinct ways to find that. Let's have a look at some questions. Okay, now this is coming from some IB papers, of course. So the first one says that line L is given by the equation 3y plus 2x equals 9, and point P has a coordinate 6, negative 5. Alright, now the first question, although it's not in this particular topic that we're doing, well, not topic, but this particular lesson, we will do it. How do we know that P does not lie on the line? Well, we've got an x and a y coordinate. I'm simply going to sub it into my equation. So 3 times my x coordinate plus 2 times, oops, that should be my y coordinate, sorry. So 3 times my y coordinate of negative 5 plus 2 times my x coordinate of 6, and that should equal 9. So we're going to sub that in when we get evaluated. That gives negative 15 plus 12 equals 9, and negative 15 plus 12 equals negative 3 equals 9, and that certainly is not true. I'm going to throw some not equal to signs and say therefore 6, negative 5, or P, does not lie on the line. Okay, some people might do things like LHS equals, so left hand side equals, RHS right hand side equals, and then show that they are not equal to. It's pretty much the same thing. Alright, that's the first part. Part B asked me to find the gradient of line L. Okay, so we'll know from here that I don't have any coordinates, so this is going to be an equation form. But remember, we need to rearrange this to make y equals mx plus c. Okay, it's the only way I can do this to find out what the gradient is going to equal to. And I think we may have even done this question previously. 3y equals negative 2x plus 9. I'm going to divide it all by 3. Y equals negative 2 on 3x plus 3. So therefore, the gradient equals negative 2/3. Okay, so that's that first method, I guess, of finding the gradient via the equation. Now C, part 1, says to find the gradient of the line perpendicular to line L. Alright, well, we now know that for perpendicular lines, if I multiply them together, I get negative 1, or the negative reciprocal. So therefore, M2 equals 3 over 2. Okay, I always like to put that first line down, m1 times m2 equals negative 1. It shows that I know my rules and the understanding behind the gradient perpendicular, so the perpendicular gradient. Now the last part of the question is a hence or otherwise. Find the equation of the line perpendicular to L and passing through point P. Okay, so we've got my gradient, as we mentioned previously. That's the first thing I've got. But now we've got the coordinate 6, negative 5. Alright, so we've got my gradient, got my point. Let's sub it in to y equals mx plus c. I'm trying to do this nice and small because I am running out of room here. Okay, so I'm going to put my y value in of negative 5. My m value is 3 over 2 times my x value is 6 plus c. Okay, well, 6 times 3 is 18 divided by 2 is 9, and I'm going to subtract the 9 across. I get negative 14, I think that is. Alright, equals c. So therefore, my equation is y equals 3 over 2x subtract 14. Alright, and that's my final sort of question and that's the aim of this lesson. Okay, so again, I'm just going to recap. Because I needed to find the equation of the line that was perpendicular to L, we first needed the gradient of L to find the perpendicular gradient, and I sub that in with a coordinate to find that particular value. Okay, the next one, remember, you can pause this and come back to it. All right, and that's the almost the same question, ladies and gents, isn't it? I'm going to go back because see what they do sometimes. They pretty much use the exact same questions in this stuff. Yeah, look at that, slightly different equation. All right, so if you want to stop this, guys, have a quick crack at it and see how you go. All right, welcome back. How'd you get on? Hopefully pretty well, I'm imagining. So part A, almost the same question. Find the gradient of L, almost the same, wasn't exactly the same. So L1 gradient, the gradient equals -2. All right, that's even easier than the last one because it's just by line of sight. Part B says to find the gradient of L2. Okay, now L2 is perpendicular to L1, all right, which means that M2 equals +1 over 2. Now remember, that's because I do the reciprocal of -2 over 1. All right, it already is a negative. I'm going to put in brackets there, M1 times M2 equals -1. That's just my reasoning behind it. I like to have that there. Part 2 wants the equation of L2. So we've got the gradient of a half, and I've also got my coordinate of 4, 5. So just like we did on that last one, I'm going to sub it into y equals mx+c. I'm going to sub in my 5 equals my half times 4 plus c. Well, half of 4 is 2. Subtract the 2, I get c equals 3. So therefore, y equals a half x plus 3. Bobby is your uncle. There you go. Okay, so another pretty straightforward question. Okay, but it is a bit hard, I guess. Okay, the last one. Now this is certainly a different style of question. Okay, the diagram here shows the points MA18 and B2410. Find the straight line and blah 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 blah. Okay, M is the midpoint. Now it says to find the value of A. I'm not going to bother about doing that because that's going to be a midpoint question. All right. For us, we're looking at the gradient of the line AB. So for part B, okay, like last time, we're just doing, now this it's our 2-point formula. So 10 take away 26 over 24 take away 0. I get, what's that going to be, -16 over 24. Now I can simplify it in my calculator, or I can simply divide top and bottom by 8. So that's going to be -2 on 3. So my gradient of that line is -2/3. Look, it goes in negative format. So yep, that looks about right. Part C just says, now this is not about an equation, funny enough. It just simply says decide whether OAM is a right angled triangle. So actually this is not an equation question, right? It's comparing the two gradients, because I know if my triangle ABO, or OAM is right angled, we need to know one of two things. We need to either know that when I multiply their gradients together, they equal -1, or you could in fact do Pythagoras. Now I probably shouldn't have thrown this question in this particular lesson, but you know what, I'm going to do it. But in order to do it, we are going to have to go and find that actual gradient. So I apologize. So hold on, let's go and have a look at this gradient. Now we need to know what A is. Hopefully remember that we get A by saying 0 plus 24 divided by 2, because that's the x coordinate of M. Okay, that's going to be give me a value of 12, so we have the midpoint there of 12, 18. That makes sense. It's halfway between 0 and 24. Okay, that makes a little bit of sense there. So if I'm to find this answer here, again, this is sort of talking about the gradients. I like this one here. This is a much easier way of doing it. Okay, I've got the gradient of AB, we've already done that. Let's get the gradient of OB. Now OB gradient would be 10 take away 0 over 24 take away 0. That gets me 10 on 24. That gets me 5 on 12. All right. And what we now need to show is that if I multiply, oops, hold on, no, sorry, my bad, I nearly did that same thing again. It's not OBZ, it's OM. Alright, read the question. Okay, so OM, we're going to find the gradient using the 18 take away 0 over my newly found 12 take away 0. So we've got 18 on 12, divide that by, let's say 6, gets me 3 on 2. Now if I look at 3 on 2, is that the negative reciprocal of negative 2 on 3? In fact it is. So therefore I'm going to put negative 2 on 3 times 3 on 2 equals negative 6 on 6 equals negative 1. Therefore, yes, it is a right angled triangle. Now, although that wasn't kind of in this particular lesson, I apologize. It's probably not a bad thing to go through anyway on a nice harder question. Look, guys, just in retrospect, just remember, please, our whole idea behind the y equals mx plus c, the two things you need to find is, of course, a coordinate, which hopefully you're given, and you have a gradient. One of the 5 ways you can find that. You whack it all into your y equals mx plus c, and hopefully you should come out with your equation of a straight line. Guys, I hope that made sense. Apologies for the longer lesson today. Any questions, please do ask. Have an awesome day.